Hello, and welcome to the Lithium Legends Senior Design Demonstration video for the spring of 2024. Today, I will be giving you a brief overview or in-person tour of our senior design project, which is an advanced battery management system that utilizes a real-time digital simulator to act upon signals and inputs to charge and discharge a lithium-ion cell. So how this works is we have our real-time simulator here, which is an OP5600 from Opal RT, which is analyzing analog inputs and outputting analog outputs to control the charging and discharging of our lithium-ion cell. So here we have a 3.7 volt, 3 amp hour capacity lithium-ion cell that is connected up to both a power supply and an electronic load, which are controlled over TCP/IP by the Opal RT digital simulator. So they're able to utilize whatever algorithms we can implement. But for our test purposes, we've been using a constant current, constant voltage charging algorithm, and then a constant current discharging algorithm. So our power supply, upon initialization, we check the voltage of the power supply or of the battery, and we check and see what the voltage of the battery is. If it's less than our threshold of our max charging battery voltage at 4.2 volts, then we go ahead and initialize the power supply into a constant current charging of 1C, which in this case is 1 amp or 3 amps, and we charge that battery until it reaches the max charging cutoff voltage, which is 4.2 volts. At that point in time, we swap over. The power supply swaps over into a constant current mode, and we begin charging the battery, and we keep monitoring the current until the current drops to about 10% of the rated capacity of the battery, so about 300 milliamps. Whenever that occurs, we know that we have fully charged the battery and we can move on to the electronic load. So we will discharge that battery, as you can see here, at an approximate 3 amps, so 1C, until we get our voltage of our battery to about the cutoff voltage, which is about that 2.75 volts. You can go ahead and turn off there. We have a power supply, which is powering our current sensor and our thermocouple amplifier. The thermocouple amplifier, which we see is right here, supports up to 4 channels, but we're utilizing 3 channels, and we have 3 K-type thermocouples, which sit on the battery and manage and monitor the temperatures, which are then reported out of their analog ports back to Opal RT. We have 2 solid-state relays, which control the switching between the power supply and the electronic load, and we're able to control and toggle those back and forth to ensure that we don't ever have both the power supply and the electronic load on at any given time. And we can now go to the back of the digital simulator, which is quite a tight squeeze. But we can see in the very back, we have these screw hole connectors, which allow us to connect to the analog in and the analog out ports of this digital simulator. And that way we are able to receive and send inputs and outputs to control all of the parameters for our charging and discharging. Upon compilation of our model, we have 2 separate subsystems that are going to be taking care and managing everything. We have a GUI, which is going to be running on the host machine, and then we have a computation subsystem that is doing all of the management and for the charging and discharging, and that is running on the real-time simulator. It's grabbing the inputs of the temperature, the voltage, and the current for the battery, and it makes decisions based off of that. It then reports back those parameters to the GUI, which we can analyze in real time. And here we can see our model running currently. So we have a current being sent to the battery of 3 amps, which means we're approximately, the battery voltage is just under that 4.2 volts for max charging voltage. So we are currently in a constant current charging phase. We can monitor the temperature of the 3 thermocouples as well as the temperature of the chamber And we are able to control the temperature of the chamber, and we currently rotate it from about 25 to 30 degrees Celsius every 10 minutes. And we're able to plot all of this data out to our workspace. And we can currently see the voltage or the current is now dropping below 3 amps. So that means we have now gone into our constant voltage phase of the charging and discharging. And if we come over here, we can see that our power supply is in constant voltage at that 4.2, and we're about 2.9 amps. And then we can see as well with the temperature chamber, we have it set to about 25 degrees Celsius, and it is charging and discharging the battery, and all of those values are then reported back.